This question is mainly testing you on your concept of speed time graph. So if you realize that the question is on speed time graph, you might want to write out two features of the speed time graph first. So the gradient of a speed time graph will give you the acceleration. And then the area under graph for a speed time graph will give you the distance traveled. So whenever you see this, you might want to remind yourself the key features of the speed time graph. And in this case, we have two cyclists. So if you want to, you might also want to indicate it with a different color so that it's easier for you to see uh, the gradient or the area under graph. Okay, so first of all, the part A, your job is to find the acceleration of A for the first 20 seconds. So if you have written down the key feature, you will know that this is the gradient. So I'm actually interested in the gradient here. So do your way of calculating the gradient. Okay, so some of you might go for the coordinate method. So some of you might go for the change in x, change in y over change in x. So it doesn't matter. So you can do you can take a look. You can do the vertical distance over horizontal distance. So whatever is it, if you have done the gradient, you will find that you will be getting 1/4. So 1/4 meter per second square. So take note of the unit. Okay, and here for part B, they actually remind you that the area under graph represents the distance, which is a feature that you are expected to know, actually. Okay, so now we are supposed to find the area. We want the distance traveled by B. So the distance traveled by B is a very simple thing. So if you go and color the area under B, so which I'm going to do it in yellow, you find that that's just a rectangle. So the area under B is a rectangle. So getting this area will represent the distance traveled by B. So that is very simple. So the distance is the area of rectangle. So this one not an issue. So most of you should be able to get it. So you will see that it's 8 times P. Okay. So subsequently, the last part is the one that usually people has issue. So there are two statements that you actually need to understand. Okay. First of all, when we say that at the starting, A is 90 meters behind B. So they don't start at the same point. Okay, and then after that, at a certain time, they actually passes each other. So the concept of passes each other can be something like A catch up with B or A meets B. So whenever they meet up, the concept will be they have traveled the same distance. So they have traveled the same distance. So that is a concept of catching up. Okay, so I'm going to illustrate to you this idea first. Okay, so first of all, you will need to understand about the 90 meter behind B. So for example, I'm just going to draw you can think about a running track. So you can think about a running track. So maybe A is 90 meter behind B. Okay, so very simple. You can just think about a person. Okay, this is person A. Okay, and then the person A is behind B. So that means, right, it's 90 meter behind. Okay, so when it hit a certain time, the two of them actually meet up. So A will have traveled all the way until here, and B would have traveled all the way until here, and eventually they meet each other. That means, right, the distance by B is shorter. So the distance by B is shorter. So there is a gap that you need to fill up. So there's a gap that you actually need to fill up. Okay, so that means, right, distance by A will be equal to distance by B plus an additional 90. Okay, so from here we will have the equation. So I already gotten the distance by B, which is 8t, but I don't have the distance by A. So distance by A is quite easy. It's just basically a trapezium and it's a trapezium and a rectangle. So I'm quite sure you know how to find the trapezium and a rectangle. Okay, so you need to work out the distance by A by doing a trapezium plus a rectangle. So you can try to work out the trapezium and rectangle. Okay, if not, you see whether you will get it correct. You can refer to my answer sheet. So eventually you will get a 10t minus 50 equal to 8t plus 90. So from here, you can solve for your t in a normal equation. So it will get you 70. Okay, so that is the whole thing on this one. So the key concept is the last part. Area under graph is the same. And then when the concept about meeting up, sometimes they will phrase it as they collide with each other. So that means, right, they already travel the same distance.